Hello everybody, this is Mr Parker from ParkerMaths.com. Today we're going to be looking at some high GCSE exam style questions on the following topics. We've got Pythagoras Theorem, right angled trigonometry, so that's involving SohCahToa, and Pythagoras Theorem in 3D. To load a copy of the questions, there's two links below this video in the description section. There's a link to just the questions and also a link to the solutions, and both in PDF format. Okay, so as you go through this, make sure you've attempted the questions before you watch the video if you want to get the most out of them. Okay, if you think you've got it right, just check the solution on the file, and if you haven't, then watch the video through, you see how it's done. Question 1, part A. Calculate the length of AC. Okay, so we've got a triangle here. AC is going to be the length along the bottom here, so we'll call that X. There's no angles given in this triangle, and we know two sides, and we want to find a third side. So for this we should be using Pythagoras. Okay, and Pythagoras says that a squared plus b squared equals h squared, where h stands for the hypotenuse, which is this long side here. So we can say that 10 squared plus x squared equals 12 squared. And if we work those parts out, we've got 100 plus x squared equals 144. If we want to get x on its own, we need to get rid of this 100, and we're going to do that by taking it away from both sides. So we get x squared equals 44. So to get x on its own, we need to do the opposite of squaring, and we're going to do the square root of 44. So if we put that into our calculator, we're going to do square root 44. If we press the fraction to decimal button, we get 6.63 if we do it to three significant figures. The units are centimetres, and we'll say how accurate we've been. Part B says a cuboid has side 2 centimetres, 3 centimetres and 4 centimetres. Calculate the length of diagonal AG. Okay, so let's find out where AG is first. That's going from here all the way up to here. Okay, so it's the longest diagonal in the cuboid. Okay, so we can extend Pythagoras from what we did in part A to 3 dimensions, and we can say that this side squared plus this side squared plus this side squared will equal this whole length squared. So I'm going to write this as AG squared equals 4 squared plus 2 squared. Now we know this length is the same as that length, so plus 3 squared. If we do that, we're going to get 16 plus 4 plus 9. 16 plus 4 is 20, so that's 29. So we can say that AG is going to be the square root of 29. Which gives us 5.39 because it's going to round up this time. So 3 significant figures. Question 2, part A. Calculate the size of angle X. So we've got a missing angle here, but we've got two sides that we know. Okay, so we're going to be using right angled trigonometry. So if I write down SohCahToa, we need to first identify which we're going to be using. Are we going to be using sine, cosine, or tan? Okay, Well, if this is my angle, this is the longest side, so we'll call that H. This is the side next to the angle, so we'll call that the adjacent side. And this is the side that's opposite the angle, so we'll call that the opposite. And the two that we're using in this problem are the opposite and the hypotenuse. So we want sine. So the first thing we're going to do, we're going to write sine. And we don't know the angle, so we're going to put an x here. Equals the opposite, which is 5.8, over the hypotenuse, which is 12.3. Okay, we want to get x on its own, so we need to remove this sign here. And to do that, we need to do the opposite of sine, or the inverse, which we write as sine minus 1. So we're going to do sine minus 1 of 5.8 over 12.3. So sine minus 1 button on a calculator is just above the sine. So we're going to use the shift button. Sine minus 1 of, we'll put a fraction in, 5.8 over 12.3. And that gives us 28.1 degrees. Question B says calculate the length AB. So that's the length from A to B. So we'll call that X. So we've got another right angled triangle, and we know one side, one angle, and we're trying to find this side here. So we'll label everything up. So this one this time is actually the hypotenuse. We know that because it's opposite the right angle. Okay, just as it was up here, look. Here's our angle, so this is the side next to the angle, so that's got to be our adjacent, which means this one is our opposite. And the two that we're interested in, we know that one, and we want to find that one. So we need adjacent and hypotenuse, which is cos. So we'll rewrite that here. So we're going to write down the formula with the information in it that we know. So we've got cos, this time we know the angle is 38, equals the adjacent, which is x, divided by the hypotenuse, which is 10.3. And now we want to find x, and at the moment it's divided by 10.3. So in order to cancel out that dividing by 10.3, we need to do the opposite, which is multiply by 10.3. That's going to remove it on this side, but we've also got to multiply this side by 10.3 to make everything balance. So we get 10.3 times cos 38 degrees equals x. So if we put that into our calculator, we've got 10.3 cos 38, which to three significant figures would be 8.12. So 8.12 centimeters. Okay, if we want to be really specific, we could say that AB equals that, because that's what we were trying to find originally. Question 3. Part A. ABCD is an isosceles trapezium. So remember, isosceles, that's going to mean that these two sides are the same, and it's marked on the diagram anyway. BF is perpendicular to AD. So this line here is perpendicular to the base. That means at right angles too. Okay, that's labelled on the diagram as well. And we want, in part 1, to calculate BF. So we're trying to find this length here. So let's call it X. Okay, so here we have a right angle triangle with two sides that we know and a third that we want to find out. So we should be using Pythagoras. And we can say that the long side squared, so 9.1 squared, is equal to the shorter two sides squared. So we can say x squared plus 3.2 squared. Now I could work those out, but I'm going to leave them as they are because it'd be easier to write things down. I want to get this on its own. So to get rid of plus 3.2 squared, I'm going to take it away from both sides. So I get 9.1 squared minus 3.2 squared equals x squared. Okay, so to get x on its own, I'm going to square root both sides, and I'm going to get the square root of 9.1 squared minus 3.2 squared. Okay, which if I put it into my calculator, it's going to give me 8.52 if I round it to 3 significant figures. Okay, part 2 says calculate the area of ABCD. Well, we know this is a trapezium. We know this base, well, we can work out this base. We know the height, and we know the short side up here. So if you forget the formula for the trapezium, it's in the front of your formula book, but it says something like this: the area equals half of A plus B H. Now H is the perpendicular height of it, so that's this length here. Okay, A plus B, that just means the long side plus the short side, and we're just going to half it at the end. Okay, so before we use this, let's work out what our values are going to be. Well, A is going to be, well, if we say that's the short side, we'll call that 6. B is going to be 3.2 plus this bit here. Okay, so we know from here to here is 6, and seeing as this is an isosceles trapezium, we know that this length here is 3.2. So 3.2 plus 3.2, that's 6.4, plus another 6, this length is going to be 12.4. Okay, for the height, we could use this, or if we want to be more accurate, we can use the exact length that we worked out on our calculator, because that's the last calculation we did. So we're going to do half of 6 plus 12.4 multiplied by, well, it's approximately 8.52. I'm going to put dot 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 because I'm going to use the number in my calculator. Okay, so we're going to do, I'm just going to put 0.5 to save me having to type a half in, multiplied by 6 plus 12.4 multiplied by, well, the last calculation I did has this length here, so if I press shift and then press this button, that's going to multiply it by the previous answer. If I do that, I get 78.4 if I do it to 3 significant figures. Oops, put some units in first. It's in centimetres squared because it's an area. And there we go. Part B says PQRS is a trapezium, calculate H. So we're trying to find this length. We've got a right angled triangle here, and we know an angle, and we know a side, and we want to find the other side. So we're going to be using right angled trigonometry. So let's write down SohCahToa. And, well, this side is opposite the angle, so we'll call that up. And this side is the hypotenuse, so we'll call that the hypotenuse, or hype. So we want the rule that involves opposite and hypotenuse, which is sine. So we're going to write down the formula with the numbers in. We're going to say that sine of the angle, which is 34, is equal to opposite, which we don't know, but it's called h confusingly when we're going to be using the hypotenuse here, divided by the hypotenuse, which is 5.2. So to get h on its own, at the moment it's divided by 5.2, so we'll do the opposite and multiply by 5.2. We get 5.2 sine 34, should have a degree sign on here, equals h. So all we've got to do is put that into our calculator. 5.2 sine 34, and we get 2.91 if we round to three significant figures. Question 4. Part A. A handrail PQ makes an angle X with the horizontal. Calculate angle X. So we have a diagram here. We've got the base of a triangle, which is 36. We've got the height is 30, and we're trying to find this angle. Okay, so it's a right angle triangle. We know two sides. We're trying to find the angle. We're going to use SohCahToa. So here's the hypotenuse. Here's the side next to the angle, so that's the adjacent, and here's the side that's opposite the angle, not touching it, that's the opposite. So we know the adjacent and the opposite, which means we're going to use tan. So we're going to write the formula down with the numbers substituted in. Tan x, because we don't know the angle, equals opposite, which is 30, over the adjacent, which is 36. If we've got tan x and we want to find x, we need to do the inverse of tan. So we're going to say that x equals tan minus 1 of, well, 30 over 36. We could cancel that down. No real need to. And if we put this into our calculator, so inverse tan, using the shift button, of 30 divided by 36, I could have used the fraction button here if I'd wanted to, is 39.8 degrees. And that's to three significant figures. Part B. Some steps are replaced by a ramp RS, so that's this length here. The ramp measures 620 centimetres and makes an angle of 5 degrees with the horizontal. Calculate RT. So we're trying to find this length here, so we'll call that X. So another right angle triangle. This time we know the hypotenuse, we know the angle, and we know this side, which is the opposite. So opposite and hypotenuse is going to be the SoH, which is sine. So sine of 5 degrees equals the opposite, which is x, divided by the hypotenuse, which is 620 centimetres. So if we want to get x on its own, at the moment we're dividing by 620. So to get rid of that, we can do the opposite and multiply by 620. So we get 620 sine 5 degrees equals x. Which gives us 54.0. centimetres. And that's to three significant figures. Question 5. A loft ladder makes an angle of 74 degrees with the floor. The distance between the floor and the ceiling is 2.6 meters. Calculate the length L of the loft ladder. So we're trying to find this length here. So we've got another right angle triangle, because we know this is along the floor and this is straight up. And we know this side, and we want to find this side, and we know an angle. So, well, this side's opposite the hypotenuse, so, sorry, the opposite the right angle, so that's the hypotenuse. This will be the adjacent that's next to the angle, and this side will be the opposite. So the problem we've got involves the hypotenuse and the opposite. So let's write SohCahToa down. So this problem involves H and O. So it's going to be a sine. So writing the formula down with the numbers substituted in, we get sine 74 degrees. Its opposite, which is 2.6, divided by hypotenuse, which is L. Okay, this is one of the harder style right-angled trig problems because the thing you want to find is on the bottom of a fraction. Okay, but we apply the rules of rearranging formula to get something off the bottom of a fraction. We multiply by whatever it is. So we're going to multiply both sides by L, because if I do that, if I'm dividing by L and then I multiply by L, them two things cancel each other out and I've no longer got anything to do with L on this side. But in order for everything to balance out and this still to equal this, I have to multiply this by L. So I've got L times sine 74 degrees equals 2.6. Okay, we've still not isolated L, but we have got it off the bottom of a fraction. So now on this side we've got L multiplied by sine 74. So in order to get L on its own, we need to do the opposite of multiplying by sine 74, which is divide by sine 74. So we're going to do that to both sides. And we're going to get L equals 2.6 over sine 74. If we put that into our calculator, we get 2.70 centimeters to 3 significant figures. Question 6. An empty box is a cuboid with internal measurements 4 centimeters by 5 centimeters by 10 centimeters. Is it possible to fit a thin, straight rod that is 12 centimeters long entirely inside the box? Well, the longest distance we've got inside the box will be from one of the corners at the bottom to this corner at the back, so a diagonal from corner to corner. So let's just draw that onto our box. So from here to here, that's the distance we want to find. And if it turns out that this distance is less than 12, then the rod won't fit in the box. So I'm going to call that length L. Now, 3D Pythagoras tells us that the distance from corner to corner, L squared, is equal to the sum of the 3 sides of the box squared. So 4 squared plus 5 squared plus 10 squared. Okay, so 16 plus 25 plus 100, which is 141. So L, if we've got L squared here, is going to be the square root of 141, which I've already drawn my calculator here, is 11.9 if I do it to 3 significant figures. Okay, so the distance from the corner to corner of the box is 11.9, but the rod is 12 centimeters. So no, the rod won't fit. Okay, always make sure with questions like this that you've actually answered the question at the end. There'll be 1 mark just for saying this, provided you've done the calculations to back it up. Now, there's another way of doing this problem which requires a little bit more understanding of what you're actually doing, but it's significantly more difficult. So the bit that I've isolated in this box, that would get you full marks. Okay, but if you can understand the more complicated way, it will help you answer some other problems that are a little bit more difficult than just corner to corner in a box. And the way we're going to do it is we're going to say, right, this diagonal here can be made into a right angled triangle with this and this. Okay, because this line goes along the bottom of the box, this line goes straight up. So in 2D we have a right angled triangle here. So if we knew this side and we knew this side, we could use Pythagoras in 2D to find this side. Okay, so I'm going to call this side here, I'm going to give it a letter, I'm going to call it B for the base, just for the minute, so that we can find that. And by 2D Pythagoras, I could say that the base squared is 4 squared, this length here, plus that squared there, plus 5 squared, which is 16 plus 25, that's going to be 41. Okay, now I could then go and work that out and do the square root of 41, but if you think about it, the next part of the problem I'm going to do this squared plus this squared, so there's no point in me actually working this out. So I could then say that this diagonal here, L squared, equals the base squared here, which I've already worked out, don't need to do anything to it, plus 10 squared, which, like on the left here, look, it's giving me 144. So L is going to equal 11.9 centimeters to 3 significant figures. Okay, this method here is a little bit more complicated for this problem, but if you understand it and you know how it works, you can use it for other shapes other than a cuboid. For example, if a pyramid comes up, you won't be able to use this method for a pyramid as effectively as this method. Question 7. An aeroplane takes off and climbs to its cruising height in 2 stages. So stage 1, the aeroplane climbs to a height of 7 kilometers and covers a horizontal distance of 20 kilometers. Stage 2, the aeroplane climbs at an angle of 8 degrees, so the horizontal, and covers a horizontal distance of 25 kilometers. So part A is asking us to calculate x, which is the angle of climb in stage 1. So we're trying to find this angle here. You must show your method. So we've got a right angle triangle here. We've got 2 sides that we know and a missing angle. So we're going to use right angle trigonometry. So let's write SohCahToa up here where we've got some space. And we've got the hypotenuse here, the side next to the angle, which is the adjacent, and the opposite here. So we want the adjacent and the opposite, which means we're going to use tan. So we're going to write down the formula with the numbers substituted in. So tan of x, because we don't know the angle, is opposite, which is 7, over the adjacent, which is 20. So to isolate x, we need to get rid of the tan, so we're going to do inverse tan to both sides. We're going to do tan minus 1 of 7 over 20. And if we do that, we get 19.3 if we do it to 3 significant figures. Okay, part B says calculate CG, the cruising height of the aeroplane. So we're trying to find this distance from here to here. You must show your method. Well, we've got another right angle triangle here, okay, and we know this length here is 25 from the bottom, and this part here, if we call it x, I'm just talking between here and here, so I'll just put an arrow on there. If I call that x, if I can find that, I already know this bit here is 7, so I can just add 7 to that and I will get the total cruising height. Okay, so we've got a right angle triangle here, we've got 25 here is the adjacent, x is the opposite, and the hypotenuse here, so we know adjacent and opposite. So again, we're going to be using tan. So we will say tan of 8 degrees is the opposite, which is x, over the adjacent, which is 25. And if we want to find x, or isolate x, get it on its own, at the moment we divided by 25, so we're going to multiply both sides by 25, and we'll get 25 tan 8 degrees equals x. And if we put that into our calculator, we get 3.6 3.51. And because that's not a final answer, I'm going to put ... here, because I'm going to use this number straight away to calculate this. So CG is going to be x, whatever that was there, plus the extra 7 from here. Okay, I don't really need my calculator to do that. I can tell that's going to be 10.5. I'm going to miss off the 1 because I don't need it if I'm going to do this to 3 significant figures. Okay, I could put 10.51. I wouldn't lose any marks because it's not specifically telling me to be a certain degree of accuracy. Okay, but 3 significant figures is generally enough for your answer, so it's 10.5.